Hello everyone, welcome back to another Geostats lecture video. And in this lecture video, I want to begin by going through the equation for the spatial lag X model. Now we're not going to go through the specific calculations because it involves a fair bit of matrix algebra, which is kind of outside of the scope of this course. But what I do want you to do is I want you to understand the pieces that are involved here. And so what we're going to do is we're going to go through the equation. And so as always, right, again, spatial lag X model is the idea that we're taking that ordinary least squares regression, right? So we're going to start with that as our base case, right? We have our prediction equals, and I'm going to use matrix notation, so hopefully that's okay. Right, we have our beta naught plus our betas times our x's, leave some space, plus some error term, right? So this whole here is intentional, right? This is sort of the default that we talked about for ordinary least squares regression, and we can label these parts. So this right here, this is our predicted y. Right, this is our dependent variable. Right, this beta naught here right, this beta naught, right, this is the intercept. And this corresponds to what we would get if all of our x's were 0. Okay? Now I'm going to use two different colors of blue here. One for the betas. Keep wanting to forget the E in beta. One for the betas. And then a different shade of blue for the independent variables. Right, so these betas, right, these are our slopes. And these betas define the relationships between our independent variables and our predicted y. Okay, so this is, again, this is general just regression review. Then over here, we have this error term. And this error term is basically whatever we didn't account for. Right, so this is all the stuff that we maybe didn't encapsulate in our data set. So what spatial lag model does is the spatial lag model includes another component. And that component is Wx theta. And Wx theta, right, this is the weighted spatial means, right? So this is the whole idea of the spatially lagged means, right? So Wx, right, this is the mean of your neighbors. Right, and this theta, right, this is the slopes. So this is theta. Right, this theta, right, this is the slope. This is the slopes. So theta is equivalent to the beta, right? But theta are specifically those coefficients that correspond to the means of the neighbors, whereas beta are the coefficients or the slopes that correspond to the independent variables. So we've got our direct variables here, and then we have what we call our indirect variables here. And these indirect variables with the weighted mean and the slope, theta, these are how we are accounting for the spatial dependency of what my neighbors are doing affects me. Okay? So hopefully this makes sense. We're going to be going through a worked example and how we interpret these results momentarily. But again, this is just the general equation, making sure that you understand the difference between the betas and the independent variables and the weighted neighbors and the thetas. Hopefully that makes sense. And as always, please reach out. Thank you.